Save the day. So sine of 2 theta is equal to 2 times the sine of the single angle times the cosine of the single angle. So let's do a problem with just this one to see how it's going to be used. We'll use a triangle one. So this is familiar to you, should be, right? So if this is theta, that's my angle. This is a right triangle. We'll say that's 3 and this is 5. That's the information we have. Now notice this is just single theta. And if I'm looking for the sine of 2 theta, I can't just do the sine of theta and double it. It does not work. Okay? So I have a problem because I cannot do op over hip because I don't have 2 times theta. I just have regular theta. So I'm going to do a substitution here. Sine of 2 theta is equal to 2 times the sine of theta, cosine of theta. Now those two I know how to do. I know how to find the sine of that angle. The sine of that angle is the opposite over the hypotenuse. And the cosine of that angle is the adjacent over the hypotenuse. So if I just find both of those, multiply them together, and then double it, that will give me the sine of twice the angle. Okay, so I have the adjacent side and I have the hypotenuse. I need the opposite. So you're going to use your Pythagorean theorem. So I have, for instance, maybe a squared. I'm looking for b squared. Remember, the hypotenuse is always over there with the c squared. And that was missed. Several of you that if you didn't get 100, there were quite a few of you that missed this, where this side was missing and you did 3 squared plus 5 squared equal to this squared. And that's backwards use of the Pythagorean theorem. So be careful. This number by itself always has to be your longest side, the hypotenuse. That's just a minor little mistake there. So b squared is 16. And so b is the square root of 16. Well, that's nice. That's just 4. Well, isn't that pretty? So I'm going to fill that 4 in right here. 3, 4, 5 is my triangle. So I have all 3 sides. So now I'm going to finish this problem. I have 2 times the opposite side is 4. The hypotenuse is 5. That's my sine. My cosine is the adjacent, which is 3, over the hypotenuse, which is 5. That 2 is a whole number. So when you're multiplying, it stays in the numerator. 2 times 4 times 3 is 24. And 5 times 5 is 25. So the answer to the sine of 2 theta is 24 over 25. Sorry. So this is the double angle formula for cosine. Double angle formula for cosine. Cosine actually has 2 of them that will give you the cosine of double the angle. So now I'm going to do my triangle example. This is obviously not drawn to scale. If that's 3, that's 4, and that's 5. And this is just theta, not 2 theta, but theta. And I want to know what the cosine of 2 theta is. I can use either definition. Personally, I think that second one's easier. So I don't know what the cosine of 2 theta is. It's not 3/5. It's not adjacent over hypotenuse. That's the cosine of single theta. So I have to do this formula to find out the cosine of 2 theta. So it's 1 minus 2 times. Here's the way I want you to write this while you're setting up. I want you to write it like that. And the reason is people mix up what that means. In your trig expression, if you have a squared or a cubed here, it means the whole expression is being squared. The reason they don't write that squared at the end is because it looks like the angle is being squared. But it will help you when you plug your values in. if you'll write it like this. That's what they mean. Those of you going to calculus, that will save you more times than not, particularly when you're doing something called derivatives. So sine squared theta means the sine of theta squared. So now you're going to fill in your values there. 1 minus 2 times. So now I need the sine of theta. Sine is the opposite side over the hypotenuse. So that's 4/5. Oh, gross. I don't like to mismatch my blue and my red. Squared. You're going to do order of operations. You got to do the squared first. So you're going to do 4/5 squared and then multiply it by 2. So that's, if you want to, you can write it like this. That's what it means. 2 times 4 times 4 is 32. 5 times 5 is 25. Again, that 2 is a whole number. It's really 2 over 1. So that 2 is only in the numerator. It's not in the denominator. And then you can't leave it like that because that's gross. Get a common denominator. You have a whole number 1. Make it in terms of 25ths. So that's 25 out of 25 minus 32 out of 25. Negative 7 25ths. That's the cosine of 2 times the angle. So here's another type of problem without a right triangle. Without a right triangle. You have the sine of single angle, and they're telling you that the sine is 15 over 17. And I want to know what's the cosine of 2 theta, and I want to know what's the sine of 2 theta. So I want to know both of those things. Okay, again, I want a different angle. I have a different angle here than my definition. So I've got to use the definitions for sine and cosine. So the cosine one, I can use that 1 minus, I'm going to go ahead at 2 sine of theta squared. I'm going to go ahead and write mine like that since we're going to do it anyway. And then it's not so bad. Because I already know what the sine of theta is. That's what they gave me. I didn't have to find it on a unit circle. I didn't have to find it in a triangle. They gave it to me. You would probably do this in your calculator, but I don't have one out. 2 times 15 times 15 is 450. And 17 times 17, I forget that one. 389, 289. 289? Okay. Again, remember that 2 is a whole number. It's really 2 over 1. That's why the 2 stays on the top. 17 on the bottom. Common denominator would give me 289 over 289. That's 1 minus my 450. Looks like that. 111. What? Don't trust me. That's the cosine of 2 theta. Cosine of 2 theta. All right, sine of 2 theta. So go back up to your other definition. Sine of 2 theta. So now we have an issue because the definition for the sine of 2 theta involves cosine. So we have some more work to do here. So all that is cosine. The definition for the sine of 2 theta is 2 times the sine of theta cosine of theta. So I'm fine with the sine of theta because they gave that to me as 15 over 17, but I have to find the cosine. So on this one, you have to draw that triangle. Yeah, that's what I want to do. Draw a triangle. Pick, it doesn't matter which of those you call theta. It doesn't matter which of those angles. You can call this one theta or the other. You're just setting this up in your mind. Okay? But I have the sine at theta, and I know sine is the opposite side over the hypotenuse. That's what you know. So I know 15 is across from my angle, and I know 17 is the hypotenuse. So now you're back to that old skill. Find the adjacent and then use it for cosine. Yeah. So you got to do your a squared plus b squared equals c squared. But just remember, yeah, you got c squared. Oops. Oh, look at that. That is so pretty. So again, you had the hypotenuse was 17. So it's a squared plus 15 squared equals 17 squared. Or you could have 15 squared plus b squared. It doesn't matter what you call a and b. You just have to make sure you have that 17 squared on the other side of the equal sign. Move your 225 over. You're left with 64. That means the missing side is a nice whole number of 8. So now I fill in my second fraction. My cosine is the adjacent side over the hypotenuse. And you're multiplying everybody straight across, and you get 240 over 289. And that's the sine at 2 theta.